When dealing with a 400 amp circuit breaker requiring a 500 coil THHN wire, which has an ampacity of 430 amps at 90 degrees Celsius in a raceway, and a distribution block limited to #4/0 wire size, several options can facilitate a safe and code-compliant connection. It is imperative to first verify the circuit breaker specifications. Ensure the circuit breaker is specifically rated for a wire size up to 500 mil. Secondly, confirm the distribution block specifications. Double-check that the distribution block is indeed not rated for wire sizes larger than #4/0. Having confirmed these limitations, consider the following options for connecting the power distribution. First option involves using a terminal lug. Select a terminal lug that is rated for 500 mil wire and is compatible with the circuit breaker. Connect the 500 mil THHN wire securely to this terminal lug. Subsequently, use a smaller wire, specifically #4/0 or smaller, to connect the terminal lug to the distribution block. This effectively adapts the larger wire size to the distribution block's capacity. The second option entails utilizing a tap conductor. Install a tap conductor, for example, a 250 mil THHN wire, between the 500 mil wire and the distribution block, ensuring the distribution block is rated for #4/0 wire. Connect the 500 mil wire to the tap conductor using an appropriate and listed splice connector. Then, connect the tap conductor to the distribution block using #4/0 wire. This method allows the larger wire to be reduced in size for the final connection to the distribution block. A third option involves employing a sub-panel. Install a sub-panel equipped with a circuit breaker rated for 400 amps and a distribution block capable of accommodating 500 mil wire. Connect the 500 mil wire directly to the sub-panel's distribution block. Finally, connect the sub-panel circuit breaker to the main distribution block using #4/0 wire. This approach isolates the large wire connection within the sub-panel. In all scenarios, several additional considerations are crucial for ensuring a safe and reliable electrical connection. Firstly, ensure that all connections are properly made and torqued according to the manufacturer's instructions. Proper torque is critical for maintaining a secure and low resistance connection. Secondly, apply an antioxidant compound on all connections to prevent corrosion. This compound helps maintain the integrity of the electrical connection over time, especially in environments prone to oxidation. Thirdly, strict compliance with all applicable National Electrical Code, or NEC, requirements is mandatory. The NEC provides detailed guidelines for safe and proper electrical installations. Delving deeper into each option, when using a terminal lug, it is vital to select a lug that is specifically designed for the wire size and material being used. Terminal lugs come in various materials such as copper and aluminum and must be compatible with the conductor material to prevent galvanic corrosion. The lug should be properly crimped or bolted onto the 500 mil wire using the appropriate tools and torque specifications. The connection between the lug and the smaller wire #4/0 or smaller should also be secure and properly insulated. For the tap conductor option, the selection of the tap conductor size is critical. The tap conductor must have an ampacity sufficient for the load it will carry. The NEC provides guidelines for determining the minimum size of tap conductors based on the overcurrent protection and the load requirement. The splice connector used to connect the 500 mil wire to the tap conductor must be listed for the specific wire sizes and materials being joined. The connection should be properly insulated to prevent shorts and ground faults. When using a sub-panel, the sub-panel must be sized appropriately for the load it will serve. The sub-panel's circuit breaker must be rated for 400 amps to protect the 500 mil wire. The distribution block within the sub-panel must be rated for 500 mil wire. The connection between the sub-panel circuit breaker and the main distribution block using #4/0 wire must be properly sized and protected. Referring to specific NEC articles, Article 310 addresses conductors for general wiring. Table 310.16 provides ampacity ratings for conductors based on insulation type and temperature rating. For example, THHN conductors have a higher ampacity rating at 90 degrees Celsius compared to conductors with lower temperature ratings. Article 240 covers overcurrent protection, including circuit breakers and fuses. It specifies the requirements for selecting overcurrent protection devices based on the conductor ampacity and the load requirements. The circuit breaker must be properly sized to protect the 500 coil wire from overloads and short circuits. Article 408 addresses switchboards and panel boards. It provides requirements for the construction, installation, and wiring of panel boards, including the use of distribution blocks. The distribution block must be listed for the specific wire sizes and materials being used. Article 110 contains general requirements for electrical installations. It emphasizes the importance of proper workmanship, equipment listing, and compliance with the NEC. All electrical connections must be made in a neat and workmanlike manner, and all equipment must be listed by a recognized testing laboratory. Considering specific product examples, for terminal lugs, manufacturers like Panduit and Bendy offer a wide range of lugs suitable for 500 mm wire. These lugs are available in various materials and configurations to accommodate different types of connections. For splice connectors, companies like 3M and Tyco Electronics provide connectors specifically designed for splicing large conductors. These connectors are typically insulated and provide a reliable electrical connection. For subpanels, manufacturers like Square D and Eaton offer a variety of panel boards suitable for use as subpanels. These panel boards are available in different sizes and configurations to accommodate different load requirements. Remember to always consult the manufacturer's instructions for specific installation procedures and torque specifications. Proper installation is critical for ensuring a safe and reliable electrical connection. Also, be aware of local electrical codes and regulations, as they may differ from the NEC. Always obtain the necessary permits and inspections before beginning any electrical work. In addition to the aforementioned options and considerations, it is worth noting the importance of proper grounding and bonding. Grounding and bonding are essential for providing a safe path for fault current to return to the source, which helps to prevent electrical shock hazards. All electrical equipment, including circuit breakers, distribution blocks, and subpanels, must be properly grounded and bonded according to the NEC. Article 250 covers grounding and bonding requirements. It specifies the methods for grounding and bonding electrical equipment, including the use of grounding electrodes, equipment grounding conductors, and bonding jumpers. The grounding system must be properly designed and installed to ensure effective fault current protection. Furthermore, surge protection should be considered, especially in areas prone to lightning strikes or voltage surges. Surge protective devices, or SPDs, can help to protect electrical equipment from damage caused by surges. SPD should be installed at the service entrance and at downstream panels to provide comprehensive surge protection. Article 280 covers surge arresters. It specifies the requirements for installing surge arresters to protect electrical equipment from voltage surges. The surge arrestor must be properly sized and installed to provide effective surge protection. In summary, connecting a 500 mm wire to a distribution block that only accepts up to #4/0 wire requires careful planning and execution. The three main options are using a terminal lug, using a tap conductor, and using a subpanel. Each option has its own advantages and disadvantages, and the best option will depend on the specific application and the available equipment. Regardless of the option chosen, it is essential to follow all applicable NEC requirements and manufacturer's instructions to ensure a safe and reliable electrical connection. Proper grounding, bonding, and surge protection should also be considered to enhance the overall safety and reliability of the electrical system. By following these guidelines, it is possible to safely and effectively connect large wires to smaller distribution blocks.